Ever wonder what's happening behind the scenes when you Google something? Or have you always just chalked it up to magic? Simply put, when you search for something, Google combs through its giant database of web content, finds the information relevant to your query, and returns billions of results all within a fraction of a second. So how do companies like Google find what you're looking for among hundreds of billions of web pages? How do computer programs even find information in the first place? Both of these questions can be answered through the use of searching algorithms. Let's start off by defining the word algorithm. Simply put, an algorithm is a set of step-by-step instructions that can be used to solve a problem or complete a task. We use algorithms all the time in our daily lives. The recipe to make your favorite sandwich can be considered an algorithm. So are the notes you play on the piano and the route you drive to get home from school every day. Algorithms are everywhere. So now that we know what an algorithm is, a searching algorithm is then a set of step-by-step instructions that can be used to find information that's stored in some place. From finding the least expensive plane ticket to New York, to withdrawing money at an ATM whose database could consist of millions of clients, searching algorithms are used all the time, everywhere. So now that we know what searching algorithms are, let's take a closer look at a couple examples. In this video, we're going to cover two different searching algorithms, linear and binary search. Let's take a look at just linear search for now. Imagine you were in a bookstore and you wanted to find a certain book. You find the shelf where the book should be located, but none of the books are organized in alphabetical order. How would you go about finding the book you were looking for? Well, you might start at the beginning of the bookshelf and look at each book one by one until you found the book you were looking for. This is exactly how linear search works. Simply put, linear search is a searching algorithm that involves checking each element of a list one by one until a match is found or the whole list has been searched. Now, let's see how to implement linear search by taking a look at some pseudocode. Pseudocode is a simple way of writing programming code in English, and it is not an actual programming language. Now all of this might look pretty confusing, so let's just start from the top, work our way down to the bottom, and explain things as we go along. So, at the very top, we can see two variables, highest position and current position. A variable is just a named storage location that contains some information. In this case, they both contain position numbers. Highest position contains the number 2 because that's the highest position in our bookshelf. Current position keeps track of where our current position in the bookshelf is. Our bookshelf starts at position 0, and we want to start searching from the beginning of our bookshelf, so the value of our initial current position will be 0. Next, we have what's called a while loop. This is used to execute any code inside of the loop over and over, as long as this condition is true. If the condition is not true, then exit the loop and we're done searching. Every time you loop back to the top, you have to make sure your condition is still true in order to keep looping. For our example, our condition basically says that as long as our position number doesn't go over the highest position in the bookshelf, keep looping. Inside, we have an if statement. Simply put, if the condition is true, then go inside and execute the code. In our example, if the book at our current position in the bookshelf is equal to book A, go inside, say we found book A, and then break out of the loop. Finally, at the very bottom, we have our current position variable with 2 plus signs at the end of it. The 2 plus signs basically increases our current position by 1. So, in plain English, every time we reach the bottom of the loop without finding the book we were looking for, move 1 position up in our bookshelf. So now, let's find book A in our bookshelf. We set our highest position to 2, our current position to 0, and then check the condition of our while loop to see if we go inside. Our current position is less than the highest position in the bookshelf, so let's go in the loop. At this point, the book at position 0, which is book U, is not equal to book A, so we won't go inside of the if statement. We'll add 1 to our current position variable and return to the top of the loop to recheck our condition. Our current position is still less than the highest position in the bookshelf, so we'll go through the loop again. The book at position 1 is not book A, so we'll skip the if statement, add 1 to our current position again, and return to the top. Our current position number is equal to our highest position number, so we'll go in the loop. At this point, the book at position 2 is equal to book A, so we'll go into the if block, say we found book A at position 2, and break out of the loop. Congratulations! You just found book A by using linear search. Now let's say we had a bookshelf where the books were sorted in either alphabetical or numerical order. With a sorted bookshelf, we could then use another searching algorithm called binary search to find any book we were looking for. Simply put, binary search is a searching algorithm that finds information in sorted lists by having the search pool with each comparison. In relation to our bookshelf, the idea of binary search is to start at the middle of our bookshelf and divide the books into 2 halves. If the book we were looking for is equal to the middle book, then we found the book. If the number of the book we want has a number that is less than the number of our middle book, just focus on the left side. If the number of the book we want has a number that is greater than the number of our middle book, then focus on the right side. Either way, find a new middle point among your new range of books and repeat this process until you find your book. For a better understanding of binary search, let's look at some pseudocode. You might notice some familiar components. We have our variables, our while loop, and our if statements. Since there's more going on here than there was in linear search, this provided chart will keep track of the values of the variables as they change. Since we now understand how these components work, let's just jump right in and work through the code to find book 50. Starting from the top, we set our low position variable to 0 and our high position variable to 14. Our low position variable is less than or equal to our high position variable, so we'll go inside of the loop. We now have a middle position variable here with some math on the right to calculate the middle of our bookshelf. Our middle position is now equal to 7, so let's head on over to our first if statement. The book at the middle isn't book 50, so we'll go on to the next if statement. The book at the middle does have a lower number than the book we're looking for, so we'll go inside. Again, we have some math on the right that will set our low position variable to 8. The next if statement is false, so we'll skip it, loop back to the top, and check our loop condition. It is still true, so we'll go inside and update our middle position number to 11. We'll then go to the first if statement and check its condition. The book at the middle position still isn't book 50, so we'll go to the next if statement. The book at the middle isn't less than the book we are looking for, so we'll go to the final if statement. The book at the middle is greater than the book we are looking for, so we'll go in the if statement and update our high position number to 10. We'll loop back to the top, find that our condition is still true, and go inside. We'll update our middle position number to 9 and check the condition of our first if statement. The book at the middle position is the book we're looking for, so we'll go inside, say we found the book at position 9, and then break out of the loop. Now in terms of search speed, it only took 2 full loops to find the book at the 9th position with binary search. If we used linear search, it would have taken 9 loops to find the book at the 9th position. So while binary search won't work on unsorted lists, when it comes to the speed of searching sorted lists, binary search has linear search beat. While we've been using bookshelves throughout our examples, programmers use virtual bookshelves called arrays that can store anything from numbers to pictures of dogs to even books. And sometimes we're not even dealing with arrays at all. Sometimes we're searching through things like trees and linked lists and all types of crazy looking data structures. But that's a video for another time. The intent of this video is to just provide you with a basic understanding of how computers find things, and hopefully it's accomplished that. Hopefully you now recognize just how important searching algorithms are to maintaining the many functions of our daily lives. More importantly, hopefully you now realize that you don't have to be Einstein or a math whiz to understand things like searching algorithms and linear and binary search. Computer science can seem intimidating to a lot of people, and a lot of people quit before they even begin. But with a little patience and determination, hopefully this video reinforces the idea that you can learn anything you put your mind to, even how a computer program finds information. Thanks for watching.